this is M7. Basically, questions 2, 3, and 4, they are similar, so I will do the most complicated one. And we have done a lot of these actually in the lectures, but some of them are symbolic, some of them are incomplete. So let me solve these questions like completely numerically, and then hopefully it helps clarify what's going on. So first there is a typo, and I fixed it already in the homework, so it should be okay for you. We don't have the B value, so we only need A and C. And here the question is asking what's the probability of A is 0 and C is 1. So the first thing we need to know is whether they are independent. If they are independent, then we only need to calculate the probability that A is 0. So let's see, the structure, the network structure is B as a common cause of A and C. So without B being given, A and C are not independent, so we cannot just write it as probability of A. So let's use our formula. A is 0, C is 1, given C is 1. Okay, so let's figure out the numerator and the denominator separately. So the numerator is the simpler one. We just need to add B because B is related to them, and then we just marginalize B. So take B out basically. So the way to do it is the same thing. Add B is 0, and then sum up over all possible values of B. Okay, so let's start with the first part. Remember in class, this drawing probability is just the product of all the variables given the parent. So let me explain that again. So basically we can decompose this into A given C is 0 and B is 0. But given B, A and C are independent. So we don't actually need C, so we only need the parent of A. So here is B is 0. And then we have C is 1 given B is 0 for the same reason. And then at the end, B does not have a parent, so B is 0. We should have all of these things from the table. So let's see, the first one is A is 0 given B is 0. It's this one here, except for A is 0. So A can only be 0 or 1. So if it's not 1, then it's 0. So it's 1 minus 0.53. And C is 0 given B is 0. You have this exactly here. So to 0.26. And B is 0 is just B is not 1. So it's 1 minus 0.66. Okay. So let's do the other one very quickly, because we don't want to write all of these down every time. So here, A is 0 given B is 1. What's that? This thing. So the first term is 1 minus 0.28. Second one is C is 0 given B is 1. We should have that exactly, yes. So times 0.12, and B is 1, we have it, 0.66. So that's how you write these things down quickly, and you just add them up, then you get the numerator. Now let's move on to the denominator. It seems it's harder, but it's just 4 terms, so it's not like exponentially harder. So let's write down all of them. So we don't know A and B, so A and B can be 0, 0, and C is 1. A and B can be 0, 1, C is also 1. A and B can be 1, 0, C is 1, and 1, 1, C is 1. And then we just add them up, and then we're done. So it seems we need the table again, so let me paste everything. Let's make the table a bit larger. Okay, so instead of, again, writing everything down, let's just directly write down the numbers. So here, the first term is 0 given B is 0. A is 0 given B is 0. Wait, which one it is? This one. 1 minus 0.53. And C is 1 given B is 0. What's that? This 0.26. And at the end, B is 0 is just 1 minus 0.66. Sorry. And second term, A is 1, A is 0 given B is 1. What was that? So this thing, just 1 minus that. C is 1 given B is 1. We should have that 0.12. And B is 1, 0.66. Next, A is 1 given B is 0. We should have that exactly. And C is 1 given B is 0. We have that. And B is 0. So 1 minus 0.66. Right? So you can factor some of these, and there are actually some tricks like to make computational faster, but I'm not going to do it here. I just want to go through this slowly and show you each single term. And at the end, we have the last one. You can probably find a pattern, but I'm not going to do that too. A is 1 given B is 1, so it's 0.28. And the next one is C is 1 given B is 1. Where is it? This one is 0.12. And at the end, B is 1. So these are very nice. So what we do is add all 4 of these up, and then we get our denominator here. So one thing you might want to notice is that a part of this is always the same as the numerator. So you may not want to compute these things twice. So if you look at the first 2 terms, these two, they are actually the same as these two. So, and it's actually always true. So you may want to save some computation there. And sometimes you may want to write down the whole thing so that you can actually factor some terms out as well. But I guess that's basically all you can do. And in general, these are hard to compute, but you can use a calculator. Or you can just type in the long expression and click calculate here.